So let's have another example. So given function at a, b, q, c, we have a naught, b naught, q naught, z naught, plus a naught, b naught, q naught, z, plus a naught, b, q, z naught, plus a naught, b, q, z. Okay, we're going to get the function at a, b, q, z and the complement function a, b, q, c. So we're going to get the mean term list. Mean term list can be directly derived from SOP only. Don't forget that. Okay, so we have a naught, b, q naught. So convert each to its equivalent binary value. So don't forget the complemented is 0, uncomplemented is 1. So this is the equivalent. A B naught Q naught Z naught is 0, 0, 0, 0. A naught B naught Q naught Z 0, 0, 0, 1. A naught B Q Z naught 0, 1, 1, 0. And A naught B Q Z 0, 1, 1, 1. So let's convert this into decimal. So we have 0, 1, 6, 7, and then that will be the subscript. So therefore, our midterm list is M0 plus M1 plus M6 plus M7. Okay? And for the complement of the function, so the result will be M2 plus M3 plus M4 plus M5 plus M8 plus M9 plus M10 plus M11 plus M12. So how do we get that? How do we get this answer? So don't forget, in the original function, these are the values that give us 1, 0, 1, 6, 7. So therefore, not part of this list has a value of an output of 0. So therefore, when we get the complement, these values are the values that will give us 0 when we get the complement of the function. So therefore, any values that is not part of this list will give us 1 in the complement function. So which are this midterm. Okay? So this is the complete list of the midterm. Okay? So that is the relationship between the max term, min term, and the function and the complement function. So another example, AB plus AC naught plus A naught C, two canonical SOP or SOM. So unfortunately, in this example, we have a missing variables. So if you notice on the previous examples, all variables are present when we transform a product term to its equivalent min term, or even sum term to max term. So everything, all variables should be present. So how could we convert these 2 or 3 terms if the variables are not present, are not all present? So it means we need to introduce the missing variables. So for example, okay, for AB, so we're going to introduce the variable C to our equation. So when we introduce C, it should not change the value AB. So how could we do that? So we're going to introduce both C naught and C to our equation. Okay? So if you're going to simplify ABC naught plus ABC, it's still AB. So we're just going to get the unsimplified version of AB. So we introduce C naught on the first term and C on the second term. Okay, so derive A, B, C naught. This is 1, 1, 0, so we have M6. 1, 1, 1, we have M7. For AC naught, we're going to introduce B based on this order. So it will be at the middle of A and C. Okay, so introduce B naught on the first term, B on the second term. So if you're going to ask me, how could we determine how many variables are going to, or how many patterns are going to introduce to our term? It depends on the number of missing variable. So you're going to use the power of two rule. If it's one variable, it means you're going to get two patterns. If we're missing two variables, it means we could derive four patterns. If it's three, it means 2 raised to 3. It means 8 patterns could be derived or could be get from that term. Okay? Because we need to introduce all possible combination of that variable or variables. Okay? So going back to AC naught, so we're missing one variable, so it means we're going to get two terms. So one for B naught and for B. So this is 1, 0, 0, we have M4. 1, 1, 0, 1, 1, 0, we have 6. So we have M4 plus M6. How about A naught C? So same procedure, we're going to introduce B at the middle of A and C because based on this order, B is at the middle. So we have A naught B naught C and A naught B C. For the first term, we have 0, 0, 1, which is equivalent to M1. A naught B C, this is 0, 1, 1, which is equivalent to M3. Okay, so since we already introduced all variables all on all product term, now we could derive the SOM. So just list all the mean term that we derive from the three original product term. So we have M1, M3, M4, M6. We don't need to write 2M6 since 2M6 is just 1M6. So write just 1M6 and then we have M7. So final answer, okay? We have 1, 3, 4, 6, 7 as your midterm list. Okay? Another example. A added to A plus C naught. A could be considered as product term or sum term. Okay, so we don't have a problem with that. So for the first term, two variables are missing. For the second term, we're missing one variable. So therefore, first term, 4 terms will be derived. Second term, 2 terms will be derived. So for A, introduce B and C, all combination of uncomplemented and complemented version of B and C. So we have A plus B naught plus AB, okay? And then introduce C naught and C. So now we have 4, okay? So all combination of B naught, B, C naught, C will be derived from A. So we have 4 terms. So we're going to get all equivalent of this sum term to max term. So A plus B naught plus C naught. This is 0, 1, 1. That's why we have max term 3 here. 0, 1, 0. It's 2, max term 2. A plus B plus C naught. We have 1, 1, 0. It means, sorry, this is 0, 0, 1. So we have 1, M sub 1. A plus B plus C, 0, 0, 0. So we have M sub 0. So that will be our max term for A. How about A plus C naught? We're going to introduce B at the middle of A and C naught. Since based on the order, it's at the middle. So we have A plus B naught plus C naught for the first term, and A plus B C naught plus C naught for the second term. So let's convert 0, 1, 1 and 0, 0, 1. So we have M3, M1. Then everything will be combined to get the max term list. So the answer will be product of max term 0, 1, 2, 3. Again, even though we have 2M3, 2M1, it will be considered as 1M3 and 1M1. So that's why we only have 4 values here. Okay? Product of max term 0, 1, 2, 3. So that will be our answer. Another example. Let's get the mean term of the given example, get the max term, get the mean term of the complemented of the function, and get the max term of the complemented of the function. So ABC naught plus B naught. Let's get the midterm list first. So let's start with ABC naught. So it's 110. So we have M6. And how about B naught? We're going to introduce both A and C, first variable and third variable. And also it means we have 4 patterns to be derived on B naught. So we have A naught B naught plus A B naught, then introduce C. So now we have 4. And okay, each term, this is the equivalent, 0, 0, 0, 0, 0, 1, 1, 0, 0, 1, 0, 1. Again, complemented in SOP are variables which are equivalent to 0. Uncomplemented, 1. Okay, so through B naught, we have M sub 0 plus M sub 1 plus M sub 4 plus M sub 5. So together with the first term, we have this list. Summation of max term, a mean term rather, 0, 1, 4, 5, 6. And to answer B, okay, just determine the values which is not part of the mean term list, which are 2, 3, and 7. Okay, and for letter C, mean term or of complement function. So we're going to base it based on the max term list of function f. Because now, if we're going to get the complement of the function f, max term will give us an output of 1. Okay, the original max term will give us an output of 1 when we get the complement of that function f. So therefore, letter C, the result is complement of f, summation of mean term 2, 3, 7. Okay, and for letter D, definitely any values which is not part of the mean term is part of the max term, which are 0, 1, 4, 5, 6 for the inverse function, okay, of f, a complement of function f. Okay, so that's it for this video lecture. See you on the next. Thank you for listening.